Hi guys, BuildZoid here, and today we're going to be taking a look at the Gigabyte B450M Gaming. So this is a motherboard that, as far as I'm aware, is not actually available in the US. Here in the UK, you can have it for 75 quid, and I think it's also available in Asia. So I'm not sure why it's not available in the US, but it is available in Europe, it's definitely available in the UK at least. And I asked Gigabyte to send me one of these, and I did get one. So thanks to Gigabyte, I did get one because that's a big heatsink. So they're kind of doing that same thing MSI is doing, where the heatsink now doubles as an I/O cover. It essentially looks like it takes up like this area of the motherboard. So it covers some of the I/O, so it acts as a I/O cover. And yeah, the big heatsink. And as you can see, also, it has, like, I mean, this is not ideal thermally, because if you just consider how much material you have, like, you'd probably get better thermal performance out of something like this, just because the heat would have to travel less distance to occupy all the surface area, right? Because because your goal with any kind of heatsink system is to make the temperature difference between the surface of the heatsink and, well, you want a lot of surface at a very high temperature relative to the air temperature, right? Because your goal is to get the best possible transfer of heat from the heatsink to the air. The only way to really do that is either more airflow or more temperature delta, which really more airflow just is a temperature delta thing, okay? Because if you push more fresh air through, well, fresh air has a lower temperature than air that's been getting heated up, right? So the thermal transfer is entirely tied to the temperature delta. But the issue is basically, like, this area will be, like, pretty hot. This area less hot, less hot, less hot, less hot, potentially cold, right? So this is kind of less than ideal. Really, like, but it's still it's still big, though. So it's still rather heavy. It still has a lot of surface area, and it probably works just fine. We'll see how it does when I test it. But, it's not an optimal design, but it's better than, what we tend to get on a lot of motherboards, which is, like, I think the predecessor boards basically had, like, a C shape. And that was it. Like, it was much smaller than this heatsink. So, yeah. It's not optimal, but it should work a lot better than what you find on a lot of other motherboards just because of the size. So that's one reason why I was really interested in testing this board. And the other reason is there's only 2 memory slots. And this is an MATX motherboard, right? I mean, it's a reduced sized MATX, because you can see that, like, normally there's, like, a third screw hole over in this area, and the board ends before it gets to that. But this is an MATX motherboard, and it's not ITX, right? So I was really interested in testing it because, it has 2 memory slots. It should be, like, it could be pretty good at memory overclocking. I didn't expect it to be great because, well, there's a lot of things that are just kind of missing on this motherboard. I mean, like, the memory power still has its own little input filtering choke up there, but this doesn't. Normally there's a choke somewhere around the 8-pin power connector for your CPU that's there to basically block the switching noise from the VRM, from basically coming out the 8-pin power connector, coming down the 8-pin power connector. Yeah, see, inductors cost money. This motherboard is cheap. You can't have inductors on it. Now, that's ultimately, I don't think that makes a huge difference, but it is just worth pointing out that that's the kind of sacrifices you start seeing when your motherboard costs £76. The other thing is, there's only one BIOS. This is a Gigabyte motherboard with one BIOS. This is very rare. Gigabyte likes to put dual BIOS on pretty much everything, but yeah, this right here, one BIOS only. Because 2 BIOS chips would, again, be too expensive. So this thing is, like, super, like, honestly, as far as I'm concerned, this is pretty much as low as I would want to go when it comes to motherboards, right? Especially if I wanted to run, like, even a 2700X at stock, I would not go below this. Just, like, this would be kind of where I'd stop in terms of, this is pretty much the bottom of the barrel as far as I'm concerned. If you go much below this, the boards just get Because the thing is, like, the cheaper the motherboard is, right, the more cost is in, like, necessary requirements, like packaging and shipping, right? Like, the shipping cost of the motherboard becomes a more and more significant part of the total price. The packaging starts being, like, somewhat significant as a part of the total price. The 24 pin is suddenly, like, basic things like power connectors and BIOS chips and freaking input filtering inductors start suddenly being, relatively expensive. So that's why it's just like basically build quality for motherboards kind of drops off a cliff at some point. And this is, like, on the edge of that as far as I'm concerned. But still very interesting motherboard, especially for APUs, because of the potential for good memory overclocking. Now, is the memory overclocking actually great? I don't know. The motherboard comes with a 1.5 volt voltage limit, and that's the end of that. So it doesn't go above 1.5 volts on the memory sticks, which makes testing the maximum memory capability, maximum overclocking capability of this board rather hard. Because, yeah, if you want to max out a lot of memory kits, you need more, like, say, you'd want at least, like, 1.85 volts plus, right? Like, 1.85 or higher. This stops at 1.8, 1.5. So that's not ideal in terms of, like, being a benchmarking motherboard. For daily usage, this is fine. You wouldn't really want to go above that anyway. But, yeah, it's just, like, kind of hard to test. So, I mean, we'll still see what it does at 1.5 volts. But that is definitely, like, a limitation that it comes with. And I've not yet fully tested the board, so I'm not sure about the memory overclocking yet, for sure. But it seems pretty good. Like, honestly, I was surprised when I was able to just punch in 38x on the memory multiplier and the board still booted. Because a lot of other motherboards, you set 38x and they just boot loop. Like, they don't start. This thing actually boots up at 3800. It doesn't actually run stable, so you can't even get into Windows. It'll crash before you get there. But it does boot 3800, which is rather impressive. Especially considering just how freaking cheap this board is and how much stuff just isn't there, right? Like, a lot of other motherboards, like, have much more substantial basically everything, especially, like, filtering components. There's just more of them compared to this. So, yeah, but still, I think for, like, a 2200G or a 2400G, I already like this board. Like, I've already messed with overclocking a 2200G on it, and it works fine, except for the usual Gigabyte AM4 BIOS quirks. Like the fact that you only have offset voltage, software voltage readings are unreliable, and what else is there? Well, that's actually it. I mean, the voltage limits are too low, and there's not that many voltage controls. You get VCore, VSOC, and VDIM. That's the only 3 voltage settings you get. You can't change any other voltages on the board. So that's not a huge downside. Like, those are the 3 voltages, like, the only 3 voltages you really need that much. But still, it's like, it's just like, you can tell that anything even remotely unnecessary is just gone. Like, anything even remotely... It's not so much unnecessary. Anything that isn't absolutely necessary for the board to still run just got removed. So, yeah, it's kind of barren. Anyway, let's talk about the VRM. That's probably what everybody here is for anyway. And the VRM, as far as, like, overclocking APUs goes, is more than enough. Definitely no problem powering an APU with this. You get a 4... Oops, I've screwed up my highlights. I guess... There, so that there, and I'm doing that wrong again. That there is your VCore. It's your VCore VRM. And then above that, we have the SoC VRM, like that. And yeah, they've just kind of crammed them together like this. So that's VSoC. SoC is a 1-2-3 phase, and VCore is a 1-2-2-3-4 phase. controlled by this chip right over here, which is the ever so popular ISL 95712, which is the standard low-end voltage controller of choice for both ASRock and Gigabyte. MSI and Asus use something else, and they both use a different chip. So Asus has their own thing, and MSI has their own thing. And I'm personally liking the one MSI uses. It has a lot of LLC settings. This one doesn't support LLC settings. But on the other hand, this does run 4+ 3-phase mode, whereas the MSI one, as far as I'm aware, only goes up to 4+ 2. So, arguably, this one has better power delivery for your iGPU than what MSI uses on their low-end boards, which is another reason why I wanted to test this, because 3-phase SoC, we'll see how, like, if that has any impact. It should. Like, I'm pretty, like, I think it should have an impact, because we're at, like, such a low phase count that, you know, the difference between 2 and 3 phases should be pretty substantial. But it also depends on kind of like output filtering and that kind of thing as well. So we'll see. But yeah, it is a 3-phase for SoC power and then a 4-phase for VCore. SoC has a high side and then a low side MOSFET in each phase. So you just have one high side, one low side, which is standard. Like, that's the normal layout you normally get. But like, you can go to, you know, more, you can run more MOSFETs if you want higher efficiency, which is exactly what we have in the VCore VRM, where you have like a high side and then 2 low side MOSFETs. And the MOSFETs here are a 4C10N. So the ever so popular cheap high side MOSFET of choice for like literally everybody. I'm not a fan of this MOSFET because it's kind of terrible. It's not really that fast. It doesn't really have a low RDS on either, but it does the job. I mean, it's not the best high side MOSFET ever, but it could, like, I mean, there's really like no limit to how bad your MOSFET could be, really realistically. But so as far as motherboards go, this is pretty much scraping the, like, I don't think anybody uses anything worse than this. As far as I'm aware, I've not seen anything worse than this. There might be some motherboard that costs like $50 that actually has a MOSFET that's worse than that. But I don't think, well, if you're buying a motherboard that costs $50, I really hope it doesn't support overclocking for your own good. Anyway, so high side MOSFET in the VCore is the same. Low side MOSFET in VCore is a 4C06N, and that's also the same for the low side in the SoC VRM. So those are both the same as well. And the 4C06 is basically the low-cost, low-side MOSFET of choice for Gigabyte and I think Gigabyte. And, Asus likes to use them as well. Asus also uses a 4C09 instead of the 10. Not that that makes much of a difference. And they sometimes also use a 4C10N. So, you know, kind of similar choices as what Asus makes for their low end. 4C06 also, again, just not that great, but this board's cheap. So here I don't really see a problem with it. The main issue I have with these two MOSFETs is that they tend to pop up on motherboards that are like over $100 quite regularly. And there, especially in a 4-phase configuration, it's just like, could you, I don't know, not use these? That would be great. Yeah. But here it's fine. Like, this board's really, really cheap. So I can totally, like, I don't see a huge issue with using these MOSFETs here. And ultimately, for an APU, this is plenty. So the SoC VRM, even if you were pushing 1.3 volts, which you shouldn't really be doing, because this is something a lot of people, I'm not sure how well documented this is or how many people are aware of it. I mean, documented, well, somebody at AMD definitely has a document proving it, but I'm not sure how many people are aware of this. But your SoC voltage is also your iGPU voltage. So a lot of motherboards in the BIOS, and I've run out of space, good job me, a lot of motherboards in the BIOS have an SoC setting and then they have an iGPU voltage setting. These two settings control this VRM. This one. There's no other thing powering the iGPU. So if you set your iGPU voltage to 1.3 volts, you are also shoving 1.3 volts into your memory controller. And the Ryzen memory controller gets steadily less stable as you exceed 1.175 volts. Okay? And at extremely high voltages, like say 1.45 volts, it gets so bad that it basically doesn't run. Okay, like at that point, you can forget about the memory controller even booting settings properly. Other than that, it's also very likely to degrade at those kinds of voltages. Like, you really shouldn't run the memory controller above 1.2 volts anyway, just for safety purposes. So, yeah, with the iGPU SoC VRM, 1.3 volts iGPU voltage is not something you should actually be using in a daily configuration. Also because, like, technically speaking, 1.3 volts iGPU voltage does make your iGPU clock higher, but your memory overclocking is going to be worse, and I've got news for you. Better memory settings on Ryzen like make way more of a difference than 100 megahertz of iGPU clock. So basically, the way you should configure an APU is you should overclock the memory first, and then set the iGPU clock as high as it can go without changing the SoC voltage. Okay, like that's basically how you should overclock these. Any other way is just is not going to be as efficient, because you're going to be just sacrificing memory speed for iGPU clock, and that's not a very efficient trade, because ultimately the iGPU is massively bottlenecked by memory performance. So, yeah, anyway, 1.3 volts, 50 amps output on the SoC VRM, you'd still be looking at about 9.5 watts of heat output, which, that will get lower if you're not running 1.3, if you're running less than 1.3 volts and still pushing 50 amps out, that will be lower than 9.5 watts. It might be more like 9 or 8.5 maybe. This amount of heat, ultimately I need to test that. I think this phase is probably going to be fine because it's right next to these phases, and those have this huge heatsink on them. So, the heat will basically, if this starts getting hot, it'll just start dumping the heat into this phase over here, because there's a ground plane connecting the low side MOSFETs. So this phase should be relatively okay. Also, the A pin will soak up some of the power heat as well. These guys, on the other hand, especially this one, I'm kind of concerned. Well, it could be either one of these, really. I'm kind of concerned about, because where does the heat go? Right? I mean, if you have airflow over them, they'll be fine. But yeah, these are kind of concerning. So that is definitely something I'll be paying close attention to when testing this motherboard, because ultimately, the way I see it, this is this could be an optimal motherboard for APU setups, and not much else because of the limited memory support. Now, permanent APU builds, it could be pretty cool for that. So, yeah. But, this is not a ton of heat, but it really depends, since this doesn't have a heatsink, it could actually still be an issue. So we shall see in testing. But this is definitely not the most efficient, SoC VRM out there, but, this is cheap, this board's cheap. On the flip side, I think it would have been, if Gigabyte opted to do, if they... I'm not sure that they should have axed a phase, but I would have really appreciated if they had an extra low side in each of the SoC phases. If there was 2 low side MOSFETs in each of the SoC phases, I mean, I'd be I'd be just 100% faith in this motherboard, because it would just be that would be really cool. But yeah, as it is, it's just it'll probably be okay. Now the VCore VRM is rather a different story. So for the operating parameters for VCore, we're going to be talking about 1.4 volts out. So output voltage, 300 kilohertz switching frequency, which this is the same for both of these. So that also applies to that figure over there. And 12 volts drive voltage. And I have this confirmed that Gigabyte, we're not going to fit over there. So 12 volts drive voltage, and so they do drive this as full 12 volts. So the MOSFETs are running at their lowest possible RDS on, and the end result is that for 75 amps, which is above what an APU's CPU portion will use, you're going to be looking at about 11 watts of heat, which is going to be no problem for a heatsink of this size. Like, the heatsink should have no problem dealing with that, which is why I think this is like if the SoC VRM doesn't have thermal issues, this is perfect for iGPU or like an APU. This is just kind of perfect for that. Now, 100 amps. So at this point, we're looking at like 2600X, overclock 2600X, overclock 2600 territory. At this point, you'd be looking at about 17.5 watts of heat. And also the 1700 and like a 1700X and an 1800X also fall into this range. The 12 nanometer process from GlowFlow is leakier than the 14 nanometer process. So for a given voltage, it actually pulls more current. Anyway, so 100 amps, second gen 6 cores, first gen 8 cores sort of land in this area. And 17.5 watts of heat, like, this heatsink can probably handle that, I think. But I'm not 100% certain. And I have tested the predecessor of this VRM, and it wasn't exactly great. But the predecessor, like, the predecessor, like, this VRM, like, Gigabyte's used this VRM before. And they've used it with much smaller heatsink, and that didn't work so great. But this heatsink is huge, so this should be viable, I think. So for, like, a 6-core, this should still be a pretty solid choice. Now, for a 2700X, I would really not recommend running anything other than stock. Okay, because if you go above stock, especially if you try to do like an all-core overclock or even a 2700, right? If you tried to do an all-core overclock on one of those CPUs, you're going to hit that 125 amps pretty regularly in an all-core workload. And at that point, this VRM is going to spit out 25 watts of heat, which, I mean, if you do throw airflow at this heatsink, it's going to handle it. But I've already tested the Aorus X470 Ultra Gaming from Gigabyte, and at this kind of load, that VRM, which is it's basically like this set of MOSFETs, except you get an extra high side, so it would look like that, right? Like, that's the X470 Ultra Gaming VRM. Well, this is this one. So the thermal density on this design is higher because you have 3 MOSFETs. This is slightly less efficient than the VRM they have on the Ultra Gaming. The Ultra Gaming hits 115 degrees Celsius, if my memory is correct. So here, I mean, I don't know. Maybe this heatsink is better than what they have on the Ultra Gaming. In which case, they need to really rethink what they were doing with the Ultra Gaming. But if this heatsink, like, I don't know. I'm not sure. Like, I can't eyeball heatsink performance. I'm not sure that this is a 25 watt heatsink. But this VRM definitely needs a lot of cooling. I'm not sure if this is enough. Because there's they have a slightly better version of this VRM, and that one already has a problem at 125 amps output. So, yeah, I don't have a ton of faith in this. Like, I wouldn't overclock a 2700X on this. Now, luckily, it does have working temperature monitoring for both the VCore VRM and the SoC. So, if you're brave and you want, well, more like if you don't mind probably just jamming a fan over your VRM, then you can, stick a 2700X in this. Try overclock it, though. I will point out that, like, the load line calibration situation and the voltage control situation is still going to make that a massive pain as well. Which is, again, why I just don't think this is, like, a good fit of a motherboard. I mean, if you want to make your life difficult for yourself with overclocking, use this. Go ahead. Knock yourself out, especially with the 2700X. But really, you probably shouldn't be using this motherboard for a 2700X. But it does have temperature monitoring, so you could always just use a 2700X and then fix your cooling afterwards. But yeah, I'd like the VRM's definitely not going to be it's not going to be smooth sailing for the VRM. You're probably going to have to do something about the VRM cooling. And the overclocking experience, just because, and this is actually universal to Gigabyte motherboards using this controller. The overclocking experience with Gigabyte boards with that controller kind of sucks, okay? And the main reason is because you basically only have dynamic voltage settings, offset voltage settings, which do turn static if you start overclocking. Like, they do go, they essentially become static. It's just really hard to tell where your voltage actually is. So like yeah, this is going to be hard to overclock. Even if the VRM isn't necessarily going to overheat, it's just like I wouldn't run this for a 2700X. For an APU, I think it's great because with an APU, you basically just you can leave the CPU portion alone. You mess around with your SoC voltage. You lock your iGPU voltage so that it's like relative to the SoC voltage, it's like the same because it's a bit complicated. I'll cover that in a separate video. But basically, like, iGPU overclocking should work great. Memory overclocking seems pretty solid in my experience so far. So, yeah, for an APU, this is great. For a 6-core, it might be viable. For a 2700X, I think you're pushing your... I mean, for a 2700X, I would say you'd probably... Like, I'd go with an MSI board. Just because their BIOS handles things better, and also because they have better VRMs for 20... Like, for their B450 boards. But admittedly, they're more expensive, but still, like, either don't overclock the 2700X or don't overclock an 8-core on this or get an MSI board, like, if you want an 8-core. But for a 6-core or an APU, I think this could be a perfect fit, especially for the APUs, because there it just seems like you get the 3-phase SoC power. The vCore VRM for an APU is actually massive, like, total overkill. And the memory power, like the memory configuration, should be pretty much optimal for APU overclocking. And also, with Gigabyte, the APU overclocking actually works in the BIOS really well, in my experience. Well, it's a bit, like, again, the voltage controls, because of that ISL 95712, are a bit janky, but it does work really well. Like, once you know your way around, like, how to use it, it works fine. It's just that until then, it's kind of a pain. So, yeah, that is it for this motherboard. Oh, yeah, did I mention the fact that yeah, I did mention that they removed the extra BIOS chips. So, yeah, this is the B450M Gaming from Gigabyte, a motherboard that I think is rather interesting, mostly because of the 2 memory slots and also the big heatsinks. I actually really hope that they keep using that heatsink. Especially if this does well in thermal testing, because I will still, like I told, like, ultimately I think this is best used with a 2200, like, this is best fit for a 2400G or 2200G, and if you really want to, maybe a 2600, but I have a 2700X, so I'm still going to test it with a 2700X. If this does okay thermally with a 2700X, I want to see this heatsink everywhere, like, everywhere. Because this board is freaking 76 quid. Okay, like, this heatsink should be just standardized for motherboards from this price point up until they do a different, better heatsink, right? I don't, like, just, yeah. Like, assuming it works well, right? That's just kind of the way I see that. If you have a heatsink that works well, just use it everywhere. Don't use an inferior one, especially on motherboards that cost more. So we'll see how the heatsink works out, but actually, I wonder if this heatsink's... Because Gigabyte has... I think this hold spacing might be standard. I might be able to fit this heatsink onto the Ultra Gaming. That would be really cool. We could test it on, like... Yeah, that's an interesting idea. Yeah, I need to check that. But anyway, so... Heatsink, memory slots. That's the main things that make this motherboard interesting. The VRM is kind of standard Gigabyte. And I mean, for APUs, it's fine. For everything else, like for 6 cores, it should be also mostly fine. For 8 cores, you might be pushing it. So, yeah, that is it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I do have a Patreon. And there's t-shirts you can buy. You can find a link to all of that down in the description below. Thank you for watching, and goodbye.